Let's discuss this next question. Show that the matrix B transpose AB is symmetric or skew symmetric according as A is symmetric or skew symmetric. Okay, there are two parts of this question which have been said, which is asked over here. One is that given A is symmetric, we have to prove that B transpose AB is symmetric. The second part says if A is skew symmetric, then B transpose AB will be skew symmetric. There are two parts of this question. So let's try to attempt both of them. The part 1, first of all, let's talk about that. Is symmetric, let's read this, is symmetric according as A is symmetric. Okay, so given A is symmetric, so given A is symmetric implies A transpose would be equal to A. Let's call this statement 1. Given that A transpose is equal to A, that's given, right? Okay, what next? We have to prove that B transpose AB. To prove B transpose AB is symmetric. Okay, this is what we want to prove. And let's take a look at the proof. If you want to prove that this matrix is a symmetric matrix, let's try to take the transpose of this matrix first. So for doing that, let's begin with let a matrix C equals B transpose AB. Let C is equal to B transpose AB, which implies C transpose would be equal to B transpose AB whole transpose. This is what we have, right? This is what you'll be getting. Okay, and we know one of the properties of transpose. What is the property of transpose? The product AB whole transpose is equal to B transpose A transpose. Although there's an extended version to this as well. There's an extended version to this. What is the extended version? I'll explain that. A1, A2, A3, ... AN. If there are n matrices multiplied and we want to take the transpose, what we'll get is AN transpose, AN minus 1 transpose, ... A3 transpose, A2 transpose, A1 transpose. This is also known as the reversal law of transpose, right? Reversal law. And in case of product, what you get is the matrices multiply together. Once you want to take the transpose of that, you can take individual transpose and multiply them in the reverse order. That's what you can do. This is obtained by expanding this. Is this property written in the NCERT? No, this is not written in the NCERT. So you will not worry about that. What we'll do is we'll solve using this only. So what we have over here is there are two matrices. There are three matrices in all. Let us break them down into two parts. This is B transpose, let's say, and this is matrix AB, let us say, and we want to take the transpose. Can we do it? Yes. Once we write it as this is basically one matrix and this is another matrix. Okay, apply this property on this product. So what you get is the second matrix comes in the front and we take the transpose. The first matrix goes at the back and we take its own also its transpose as well. This is what we get. Okay. Can we get rid of this reversal law? Yes, we can get rid of this reversal law. But you will observe, I'll explain that this reversal law could be used over here as well, right? And once, let me derive this result first. So after this, what happens to C transpose is this AB whole transpose becomes B transpose A transpose. Again, I'm using that property. What happens to this B transpose whole transpose? This becomes B now. Since obviously the transpose of transpose is equal to the matrix itself. Since the transpose of transpose is equal to the matrix itself. So this is equal to this. Okay. You may please observe that I could have applied the reversal law directly on this and obtained this result directly. The order would have been reversed and we would have taken transpose of each matrix. The first matrix B transpose, the second matrix A transpose, the third matrix B transpose, that will be equal to B over here. We could have used that reversal law as well, right? Okay. So once you have cleared this with this much, what next? We haven't used this condition yet. Okay, let's use this condition. Since we have obtained this stage of A transpose, let's use that. This is B transpose. This becomes A, this becomes B, and this is using this one. Okay, so this is B transpose AB. Okay, and what is B transpose AB equal to? B transpose AB is equal to C. We started with this, right? So this gives me C transpose is equal to C. Okay, which implies C is a symmetric matrix. C transpose equal to C implies that C is a symmetric matrix. C, that is B transpose AB is a symmetric matrix. This is what you obtain, hence proved. Hence proved. That's a complete proof? Yeah, that's a complete proof. Okay, is that all? No, this is just the first part where we have proved for a symmetric matrix, right? Right. If A is skew symmetric, then B transpose AB should be a skew symmetric matrix. Okay. Now let's talk about this second part after this. Okay, let's get rid of this whole thing. So now we'll discuss this skew symmetric as A is skew symmetric. Okay. Let's discuss the second part. Given A is skew symmetric matrix. Now what does skew symmetric implies? Implies A transpose will be equal to minus A. Let's call this statement 1, which is given to us. Let's call this statement 1. A transpose will be equal to minus A. This is the definition of skew symmetric. And we are supposed to prove. What do we want to prove over here? Show that the matrix this is skew symmetric. B transpose AB is skew symmetric. Now, if you want to prove that B transpose AB is skew symmetric, we'll have to begin by taking the transpose of this matrix, right? Let's take a look at the proof. Let us assume, this matrix is denoted by D. B transpose AB is denoted by the matrix D. And now we focus on finding the transpose of D. D transpose is equal to B transpose AB whole transpose. And we just found that B transpose AB whole transpose, right? Reverse. B transpose will come first, after that A transpose, and the transpose of transpose would be actually equal to B after that. Okay, let's use this. This gives me D transpose is equal to B transpose A transpose times B. And what next? Since we have reached a stage where we have A transpose and A transpose, the value is already known, let's replace that. So this is B transpose times minus A times B using 1 over here. Okay, what is this equal to? This scalar minus 1 is multiplied with this matrix. That scalar can move around. It will not impact the matrix multiplication, and I can bring it at the front. This is B transpose AB. This gives me D transpose is equal to this. And what is this? This is something which we began with. This is equal to D. So this gives me D transpose is equal to minus D. For this matrix D, D transpose is equal to minus D implies D is skew symmetric. D, that is this matrix B transpose AB. D, that is this matrix B transpose AB is skew symmetrics, and that is what we want to do prove. At the end of the day, that is what we want to do prove. I hope that's okay. Yeah, that is okay. And this is all that you have in this question.